Look at this view of Earth today. It looks calm, stable, and perfectly safe, floating quietly in the dark. That tranquility hides a violent history. Earth forged itself through a relentless series of catastrophic cosmic impacts rather than a slow, peaceful evolution. If even a single one of these ancient planetary disasters had missed their mark, the exact conditions required to support life would never have materialized. The quiet world we walk on right now is a survivor's landscape, owing its existence to chaos and destruction. To see how this happened, we have to rewind 4.6 billion years. At this point, there is no Earth, there is no Sun. This animated diagram illustrates the nebular hypothesis. We start with a massive, chaotic cloud of dead gas and dust. As gravity takes hold, this nebula collapses inward, pulling the vast majority of the material toward a dense center. Once the pressure at that core reaches a breaking point, the central mass ignites into our sun. The leftover material stays trapped in orbit, forming vast spinning rings of microscopic dust. That initial collapse set off a violent chain reaction. Those floating dust particles were about to trigger the assembly of our planet. Out in those spinning rings, microscopic grains of dust began bumping into each other. Over millions of years, these tiny collisions forged larger, jagged space rocks, known as planetesimals. As these rocks grew, their gravitational pull increased, causing them to slam together with tremendous speed. This merging mechanism, called accretion, generated immense amounts of friction and heat. Early Earth remained a fluid sphere of churning magma and fire, kept in a liquid state by the energy of constant bombardment. Every layer of the ground beneath our feet was originally a fluid ocean of fire, assembled through continuous, chaotic impacts. Just as this sphere began to take shape, it faced an existential threat. A rogue, Mars-sized planet, often called Theia, was hurtling directly into Earth's orbital path. This simulation demonstrates the impact. The rogue planet strikes the Earth directly, ejecting tons of debris into orbit. Under the giant impact hypothesis, gravity forced those shattered fragments to coalesce, eventually fusing together to form our moon. Over millions of years, the gravitational drag of this new satellite slowed the planet's rotation and gradually locked its tilt into the stable alignment that now governs our seasons. The collision that nearly obliterated the young Earth provided the exact mechanical anchor necessary to keep the planet stable enough for life to take hold. Following the impact, the molten planet gradually began to cool down. In a process known as planetary differentiation, heavy metals like iron and nickel sank to the center to form the core, while lighter materials rose to create the mantle and the crust. As the outermost layer lost its heat to the vacuum of space, it hardened. For the very first time in Earth's history, the planet developed a solid, continuous crust. But the solar system was still packed with stray debris. This triggered the late heavy bombardment, an era where massive meteors and comets repeatedly hammered the new surface. These strikes carried a vital cargo. Trapped inside those comets and expelled from volcanic outgassing were the building blocks of our oceans, water. We often picture meteor showers as extinction events. Here, this bombardment functioned as a delivery system, pooling into the craters and eventually filling the first oceans. Move the clock forward 4 billion years. The sky clears, impacts slow down, and immense dark oceans settle under a thick, cloudy sky. Deep within these waters, simple, non-living chemical compounds began to organize into the first biological organisms, a transition scientists call abiogenesis. The iron core, the solid crust, and the nutrient-rich waters delivered from space created a highly specific, reactive chemical laboratory capable of sparking that first heartbeat. The breathable air, the liquid oceans, the steady seasons, and the solid ground. Every feature of our habitable world is the direct result of a billion-year-long chain of cosmic collisions, perfectly conspiring to build our home.